If you've ever found yourself needing to, move, join, or clean up data, you are dealing with data pipelines.
Oh, absolutely.
Whether it's syncing customer data from one system to another or prepping massive text blocks for an AI model, they're just everywhere.
They're the circulatory system of any modern company, really.
But building them can be so different depending on the situation. And I think there's a perfect analogy for this. It's like cooking.
That's a great way to put it. That's really the core of what we're diving into today.
Right.
I mean, it all depends on your skill, your time, how custom you need the result to be.
Exactly. Sometimes you just need takeout. You want it now, fully prepared.
Other times, maybe a meal kit is better, the ingredients are all there, prepped, but you're still doing the assembly.
And then, for that total control, you cook from scratch. Raw ingredients, your recipe.
And that's a perfect mirror for the 3 ways we author data pipelines. So our mission today is to unpack those 3 experiences.
We're talking no code, low code, and pro code.
Yep. We're going to define them, look at the tech behind them, and most importantly for you, dig into the trade-offs. Which one is the right tool for the job?
So we'll cover no code, which is more and more about AI agents.
Low code, the classic visual drag and drop canvas.
And pro code, which gives you all that power through Python SDKs.
That's the plan.
Okay, let's unpack this, and I think we should start with the easiest entry point.
The quickest, most accessible one.
No code. This is definitely the takeout experience you mentioned. Speed above everything else.
It really is. It's the ultimate push toward data democratization.
And when we say no code today, we're not just talking about simple wizards.
No, not at all. We're talking about interacting through chat, through plain language prompts, all driven by these powerful AI assistants.
So back to the analogy, you're ordering the dish, you don't see the kitchen, you don't prep anything, it just arrives.
Exactly. You just state the outcome you want.
So how does that work in practice? I mean,
Yeah.
you literally just ask for it.
Pretty much. You might tell an agent something like, take all customer orders from the last 30 days in Salesforce, standardize the addresses, and load them into our staging schema on Snowflake. No code, no configuration.
You just state the goal.
Right. And what's so fascinating is what happens under the hood, the mechanism there.
It's not just keyword matching.
No. The agent uses its training to interpret your intent. It infers the transformations you need. It understands the data models.
So it figures out which Salesforce fields map to which Snowflake tables.
Yes, and it does that instantly. It generates all the complex functional code required to spin up that pipeline on the spot.
So the agent is basically a super fast translator. It turns a business request into concrete engineering instructions.
Precisely. And it can go even further. We're seeing AI agents that can orchestrate entire multi-step processes.
What do you mean by orchestrate?
I mean, it can coordinate sub-agents to handle specific tasks. One for reading the data, one for cleansing it, another for writing it. It manages the whole chain.
That accessibility sounds, well, revolutionary, especially for teams that are short on data engineers.
It is. It's a game changer for people who work closer to the business side of things.
Business analysts, ops teams.
Exactly. Or marketing specialists. People who need quick answers, maybe for an ad hoc report or a small model, but they just don't have the time or the training to use traditional ETL tools.
Okay, so let's nail down the strengths. Speed and accessibility are huge. What else?
Well, the accessibility part is key. It really does empower every domain expert to be a data integrator.
So you don't have to wait in line for the data team.
Right. And second, it allows for incredibly rapid iteration. You can just tweak your prompt to change the output. Experimentation becomes super fast.
But this must introduce a ton of ambiguity. I mean, a lack of control is a terrifying thing for governance teams and engineers.
It is, and that's the first major trade-off. You have limited customization and control.
So if you have a really specific business rule,
A really nuanced transformation that the AI wasn't explicitly trained on, the agent might get it subtly wrong. And you often don't have an easy way to just jump in and fix the generated code.
and if that pipeline breaks, you're relying on a black box.
Exactly, which is the second trade-off. Debugging and auditing are much, much harder.
Because the automation hides all the details.
Right. If a compliance auditor asks why a piece of data was changed in a certain way, you can't just say, well, the AI decided to.
That is a critical point. And that speed, it doesn't guarantee the pipeline is ready for production.
Absolutely not. And that's the final trade-off. These pipelines need rigorous manual checks before they go live in a critical system.
You still need to check performance, error handling.
All of it. monitoring hooks, security policies.
Yeah.
You still have to check the takeout order before you serve it to the CEO.
That lack of granular control, it naturally pushes more experienced users away from the pure takeout model.
It does. It pushes them toward the middle ground.
Yeah. Which brings us to low code. The meal kit balance. It's still fast, still convenient, but you're much more involved in the process.
Yep. In the integration world, low code is the drag and drop visual canvas.
So instead of telling an AI what you want,
You're explicitly assembling the workflow yourself, block by block, using these pre-built components.
let's use that same example. Filtering customer orders from Salesforce to Snowflake.
Okay. So
Yeah.
you'd literally drag out a Salesforce connector node onto the screen. You type in your login details.
Then you'd grab a transformation node.
Correct. Maybe a filter component, and you'd
Yeah.
visually configure that 30-day condition. Then you drag out your Snowflake target node and connect the dots.
So it's interactive assembly. You see the whole flow.
Exactly. You're using standardized building blocks.
Yeah.
It's way faster than writing code from scratch,
Yeah.
but you have full visibility into the structure.
This approach has been around for a while in ETL tools, but it seems like modern versions are more flexible. Who's the target user here?
It's really ideal for data engineers and specialists who maybe come from older ETL backgrounds or just really value that visual clarity.
They want control over the sequence of operations.
They do, but they also want the speed and standardization that comes with pre-built tested components.
Okay, so let's talk strengths. What are the big wins with the visual approach?
The first one is execution efficiency. It hits that perfect balance between speed and control.
And because the components are standardized, you get consistency.
Right. You can make sure every single data quality check your team deploys uses the exact same pre-certified logic.
And that must really help with teamwork.
It does, which is the second major strength, collaboration and governance. A visual canvas is basically self-documenting.
So a new team member can just open it up and understand the flow without reading a bunch of code.
Exactly. They can review it, tweak it, duplicate it. It simplifies audits and governance reviews a lot.
That sounds like the sweet spot. But where does this model start to, well, break down? Especially when things get complicated.
Scalability is the first and biggest challenge. As your pipelines get more complex, that visual representation, the DAG, or directed acyclic graph, can turn into what people call visual sprawl,
A giant spider web of nodes and lines.
a complete mess. Dozens of connections tangled together. It becomes almost impossible to read, let alone audit or debug.
I can just imagine trying to trace one error through that.
And that leads to the second major drawback.
Yeah.
The pain of making bulk changes.
Oh, okay. Tell me about that.
Say you manage 50 pipelines, and you need to update a source connection or change one data type across all of them.
In a visual tool, that means.
It means hours of tedious manual clicking, opening each pipeline, finding each node, making the change, saving. It's a huge time sink for engineers.
And what if you need to do something really custom that the tool just doesn't have a pre-built block for?
That's the third trade-off, extensibility. A lot of modern low-code tools let you drop in custom scripts, maybe some Python or SQL.
But you're still stuck inside their framework.
Exactly. You're working within their guardrails.
Right.
Bringing in your own custom libraries or trying to manage it all as infrastructure as code becomes really difficult, sometimes impossible.
And that lack of total freedom is what pushes us to the final category.
Inevitably.
Pro code. This is cooking from scratch. You own everything.
This is where you use Python SDK as software development kits. It lets data engineers define, build, and manage every single part of the pipeline as code.
So there's no canvas, no chat agent.
Just code. Your script interacts directly with the data platform's framework.
So our Salesforce to Snowflake pipeline becomes a structured Python script that we write and manage.
Correct. And this is where the power of pro code really shines.
Scalability and automation.
Yes. It takes more time and skill upfront, for sure. But it pays off massively once you move beyond just one or two pipelines to managing an entire enterprise's worth.
So let's go back to that bulk change problem, the 100 pipeline nightmare. How does pro code just destroy that problem?
It's the perfect example. In the visual canvas, that's 100 manual fixes.
Which could take days.
Right. With a Python SDK, you define the change you want once. You write a simple script, maybe a lump, that goes through all 100 pipeline definitions, and you execute the change in seconds.
That's just a fundamentally different way of managing the system. You're treating the pipeline like a piece of software.
Exactly like software. And that unlocks another huge benefit, environment portability.
Moving from development to production.
Or even from one cloud provider to another. In a visual tool, that's risky and manual. In pro code, because it's all just text, you can parameterize everything, connections, variables. The code itself makes deployment across environments fast and reliable.
So this is clearly for your senior developers, your experienced data engineers who need that ultimate control and automation.
Without a doubt.
Beyond scalability, what are the other key strengths?
Well, first is just unparalleled flexibility. You have total control over logic, structure. You aren't limited by what a vendor decided to put in a node.
You can write whatever you need.
And second, and this might be the biggest one for an organization, is full DevOps integration.
Because it's code.
Because it's code. So it fits naturally into all your existing software practices. Version control with Git, automated testing, CI/CD pipelines.
Which means you can apply software testing principles to your data integration logic itself.
Precisely. You can test the integrity of the pipeline logic before it ever even touches a piece of data.
Okay, but there's a huge barrier to entry here. That skill requirement is a major cost.
It is. That's the first trade-off. It's a steep learning curve. You need real coding expertise, usually in Python, and that limits who can contribute.
And the lack of a visual is a problem for collaboration, right?
A real hindrance, yeah.
Right.
If a business analyst wants to understand the pipeline, they can't just look at a nice, clean diagram. They have to try and read a Python script.
And finally, building from scratch has to be the slowest way to get started.
It is. It takes way longer up front than asking an AI agent or dragging blocks on a canvas. You are absolutely sacrificing that initial speed for long-term scalability and control.
So we've covered 3 completely different ways of working. And if we zoom out, the real value isn't about picking one winner.
No, not at all. It's about seeing how they all fit together.
So if we were to map these out, let's say on 2 axes, maybe ease of use on one and scalability or customization on the other.
That's the perfect way to visualize it. That's the landscape data teams are navigating.
Okay, let's plot them. Where does no code land?
No code, with its AI agents, is way up in the corner of highest ease of use. But its black box nature puts it lower on the scalability and customization axis.
So lowest barrier to entry, best for quick, isolated tasks. And the low-code visual canvas, the meal kit.
That lands right in the middle. It strikes that vital balance. It's approachable, it's great for visual audits, but it hits a ceiling when complexity gets too high. That visual sprawl we talked about.
Which leaves pro code at the other extreme.
Exactly. Procode with Python SDKs is at the far end of the spectrum. Maximum scalability, maximum customization, and the deepest integration with engineering workflows.
But with the highest cost in terms of technical skill required.
Right.
So the big takeaway for you, our listener, is that a modern data platform can't just choose one. It needs all 3.
They have to converge. There is no single best authoring experience. Different people need different things at different times.
So no code is really about accelerating accessibility.
Low code accelerates execution and collaboration.
And pro code accelerates skill and automation at scale.
Perfectly put.
The real power is having the flexibility to move between them. Maybe you start a project in low code, then drop down to pro code to write some custom Python, and then maybe an AI agent monitors it.
That's the future. It's about empowering the whole organization, no matter their skill level. It's about choosing takeout, a meal kit, or scratch cooking, depending on what you need to do right now.
Which brings up a really interesting question for the future.
Go on.
As these AI agents get more and more sophisticated, making complex pipelines with no code gets easier every single year.
It does.
So, does the core skill of a senior data engineer start to shift? Will their value no longer be in writing the basic pipeline code, but instead in managing, testing, and debugging the massive complexity that can only be handled through pro code and real DevOps discipline? Something for you to mull over.
A great thought to end on.
Thanks for joining us for this deep dive into data integration authoring experiences. We'll see you next time.